Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope you all will be doing good. Today we are going to start the new industry, which is the manufacturing of the urea. Urea is one of the most important compound because it is the source of nitrogen fertilizer. It is one of the nitrogenous fertilizer. And fertilizer is a substance which is added in the soil to fulfill the nutrient content of the soil. So first of all, let me discuss what urea is. Chemically, the urea is called the carbamide, and it is an organic compound. And the organic nature is given due to the presence of the carbonyl functional group, which is attached with two ammonia groups. Urea is very much important in the life of the animals, including the mammals. It is having an important role in the nitrogen containing substances in the animals, and it is also one of the main nitrogen containing component in the urine of the mammals. It is having a carbonyl group in the center, and this carbonyl group gave it the organic nature. Now, the history of this urea production is very much interesting, as it was first developed by Frederick Waller and in 1828. Initially, he was doing some other experimentation, but accidentally the urea was produced. It was at that time when there was a concept of vital force theory. The vital force theory indicates that the organic compounds can only be synthesized from the living organism under the influence of a vital force. It means that the organic compounds were never considered to be prepared or synthesized in the laboratory outside the living bodies. But Frederick Wohler, who was a German scientist, chemist, he was doing some experimentation, and from inorganic compounds, he accidentally produced the urea. And this was the end of the vital force theory and a start of new era of preparation of new compounds. After that, the majority and numbers and millions of compounds of organic compounds were synthesized in the laboratory. Now, urea is very much important. A fertilizer, nitrogen is containing fertilizer, and it is containing the highest percentage of nitrogen in the solid fertilizer. It is about 46.67% of the nitrogen. Another important property is that it readily dissolves in water, and when it dissolves in water, so it means that there is no salt residue left at the crops. It means no wastage of fertilizer will be done if we use the urea. In addition to the fertilizer, it is also used in a daily life and also in the industrial procedure, and we will discuss the uses of the urea later on. You can see the percentage presence of the elements in urea. Urea is containing the nitrogen, oxygen, carbon, and hydrogen. Highest percentages of 46.67 of nitrogen. Then we are having oxygen 26.67%, carbon is 20%, and hydrogen is in the least concentration, that is 6.66%. Now, let me discuss the industry. First of all, the raw materials for the urea manufacturing are only two raw materials needed: ammonia, NH3, and carbon dioxide. Ammonia is prepared by Haber's process. And for this ammonia production, the atmospheric nitrogen and hydrogen are used, and they are treated under the in the presence of iron as a catalyst at a temperature of 450 degrees centigrade, and 200 atmospheric pressure will be needed. For the production of ammonia, we need nitrogen, which is obtained through the fractional distillation of air. As nitrogen is one of the major component of the air, so it is extracted from the air through fractional distillation. Then the hydrogen comes from the methane. When the methane is passed over the steam in the presence of nickel as a catalyst, so hydrogen gas will be released and carbon dioxide will be formed. Here you can see we are getting the hydrogen and carbon dioxide both. So the hydrogen produced over here is used in the Haber process along with the nitrogen to produce the ammonia, while carbon dioxide is again a second raw material which is used for the urea production. So it is that much simple. Now, basic reaction, first of all, we are reacting the both of the raw materials. The ammonia and carbon dioxide are heated. The conditions are very much important in this case. At 170 to 200 degrees C at a temperature for temperature, and 100 to 200 atmospheric pressure, and this will result in the intermediate salt formation. You can see in the reaction we are getting NH2COO NH4 positive. This is called ammonium carbamate. Keep in mind the difference between ammonium carbamate and carbamide. The urea is called carbamide, while the intermediate is called carbamate. This is a salt, and this salt NH4 will get a positive sign on it, while the COO will have a negative charge on it. It means that it is a salt. Then from this urea is manufactured. How the urea is manufactured? It will be heated, so it will decompose. When the water will be released from it, we will get the urea in the form of NH2CO NH2. This urea is in the liquid form. So this is the next step is the evaporation, and through the evaporation the extra quantity of moisture will be released. It evaporates the water from the liquid urea. Then after the liquid urea is evaporated, we will get some cooled and powdered form of the urea powder, and it will be then cooled rapidly, and it will be sent to the granulation tower. Granules will be formed. Granules means small structures, as you might have observed, as the urea is in present in the small granular form. So this will be stored to the and it will be sent to the market. This is the whole procedure of the urea. Now, in the flow sheet diagram, you can see that liquid ammonia and the carbon dioxide, when it is compressed, so they are reacted with the the reaction chamber, and this reaction chamber we will get the urea solution. This urea solution will be evaporated, and due to evaporation, you can see that unreacted carbon dioxide and ammonia will again be formed, and they will be resent to the reaction chamber. And from this evaporator block, you can see we also obtain the water, which will be having some waste in it, and this wastewater will be treated for the use of clean as a clean water. Then after the evaporator block, we got the melted form urea, which is sent to the granulation tower, from which the air will be blown in, and the excess of moisture will be released in the form of humidity. Then this granulation tower, the granules will be formed, and urea will be packed and stored for the market use. I hope the process of urea manufacturing will be clear. Now come towards the uses of the urea. The very first use of the urea is as a fertilizer. Among the 100% of urea manufactured, 86% of urea is used as a solid fertilizer. It is also used as an adhesive in the form of urea formaldehyde, and it can be used to as a glue for the plywood. You are familiar with the plywood, so when the plywood are stick together as an adhesive, the urea formaldehyde is used. Another use is in the dinnerware. Melamine formaldehyde is used as dinnerware, and it will give it the hard surface, and unbreakable dinnerwares can be produced. It can also be used as explosive, as in urea nitrate is a highly explosive, so it can be used in the explosion. It is also used in a certain important chemicals like the plastic, resin, and adhesive. It is used in the as a flame proofing agent. It will dump the flame. Fine. And then it is used as a flavor enhancing additive for cigarette. In the cigarette there comes different flavors, and one of the flavor can be because of the urea. It is used as an ingredient of the facial cleansers, as it is having the moisturizing effect, so it can be used in the cleansers and the lotion, and it is one of the main ingredient of the hair removing creams as well. Next one is the rotor de-icing. So in older ages, older times, the sodium chloride was used as a road de-icing. De means removal, and icing means removal of the ice from the roadside. So when the salt is put on the railway tracks, which are made up of the iron, so it enhances the corrosion. So instead of sodium chloride, nowadays urea is used to clean the ice and the roadways and the railway tracks as well. So then again, as I already discussed, that it is having a hydrating action, so it can be used in the dermatological products for the rehydration of the skin. I hope the topic is clear. Thank you so much. Allah Hafiz.